Okay, yes, you can hear me. Oh, great, great. Thanks for inviting me. Yeah, my talk, as was said, is called Towards Automated Evaluation of LLM Applications. And here's kind of the intro, or sorry, the agenda. So first, I'm just going to give a little bit more background of my AutoML history and kind of how I got to where I am now with LLMs. Um, then I'm just going to dive right into, I mean, everybody knows what an LLM is here, but just sort of the architecture of LLM applications and also AI agent applications. Then I'm just going to talk a little bit about just eval in that space and some of the terminology, which is different than from machine learning, and sort of introduce this idea of like development eval versus production eval, and then two other topics that are kind of tacked on are what I would call LLM analytics. So sort of data analytics on top of all the data you can extract from LLM traces and logs, and then how to test based on that data. And then the last section will be, um, you know, how are we getting towards auto eval? Is that even a good goal to have? That type of discussion. So this is, yeah, so as mentioned, I'm the chief scientist at a company called Distributional. It's just a small startup. I've been there for about a year, and we are building an automated LLM eval analytics and testing platform. And I will not talk a lot about that in the talk, but I will, a lot of the things that I'm going to talk about, that's what we do. And I've been in AutoML since, I guess I would say like around 2015, and working with LLMs since 2022. Also, as mentioned, like what I probably am most known for in the AutoML community is H2O AutoML. That was something that came out of my PhD research. I graduated with my PhD in 2015 and then immediately went to work at H2O AI to continue work on that, and that eventually became H2O AutoML, which was released in 2017. And yeah, I left H2O in 2023. This is sort of right after the whole LLM craze started to happen. The ChatGPT was released in, I think, November of 2022. So yeah, a lot of, it was kind of a shock, I would say, to a lot of machine learning companies when this happened. It's like, how do we, integrate this new technology? Everyone's focused on it, maybe too focused on it, but this is kind of what people are investing in, they want to do. So yeah, so I just kind of got into it then. And one other thing that that I might be known for is the AutoML benchmark. So that was co-created by me and several other people who are in this community as like a benchmarking platform for AutoML, because back before that, we had a lot of, I would say like that's when bigger commercial entities started getting involved in AutoML and sort of making all sorts of claims that their thing was, better than, this and that. And so uh, it just became a passion of mine to kind of like bring clarity and just, yeah, reproducibility to all these types of claims. And then, yeah, I think that really did help like the AutoML community to have a central piece of software everyone could benchmark against. And that's still an ongoing project. There's some newer stuff, as I have heard about now, that has extended on that type of work. So yeah, so I think that started the summer of 2018. I had a couple of interns at my company that are now also in this community. So, and then, yeah, I've been in benchmarking and eval for a long time. I started working on this actually in 2013 when I was working at a company that was called Wise.io, which no longer exists, but it was a short-lived startup founded by a Berkeley professor named Josh Bloom. And basically what it was, I don't know if everyone here was in machine learning back in 2013, but that was sort of the big data time. if we can all remember like the sweet times when it was just big data. And also at the time, things like random forest, GBM, that was kind of like the state of the art in machine learning. So what Wise.io did was basically they made a whole company around like very efficient, fast, scalable implementation of random forest in C++. It was a proprietary implementation. They try to make a whole company out of it. So I became an intern there in my PhD and started benchmarking against scikit-learn random forest. And that's when I learned about H2O random forest. And I was doing a lot of benchmarking and realizing like the scikit-learn implementation was not very scalable and sort of fast compared to H2O and Wise.io. And so that's when I kind of got introduced to H2O. That kind of eventually like I ended up working there, but and I think one of the consequences of a lot of this benchmarking, because we were publishing not in a paper, but just kind of blog posts and sort of talking about it, was at the time, maybe someone here could corroborate this theory, but there was basically what I inferred from a lot of GitHub conversations on the scikit-learn GitHub repo was that they then re-implemented a lot of the decision tree code, so there's now really more fast and more scalable. So like that was, I think, a consequence of a lot of this early benchmarking. So that is something we all benefit from, is like now, yeah, the scikit-learn code is actually quite, competitive compared to some of these other tools. And of course, as AutoML people, we build on top of scikit-learn and all these other tools. So it's just important to kind of get the base algorithms to be fast and efficient, because then we all benefit in our tools. And that's actually why I probably joined H2O, is because I realized they had a very efficient, scalable, fast, it was also distributed implementation of a bunch of algorithms. So that meant when I built upon that, mine would also be fast and scalable. And that's was kind of the whole theory behind H2O AutoML. The method itself was not incredibly, novel or sophisticated. It was using stacked ensembles and sort of a bespoke random grid search across a bunch of algorithms. But because I was building upon very fast implementations of things, it could be faster and actually make a lot more progress within the same amount of time. It's like some of the more like fancier methods in AutoML. So so that all of that is to say, like, I care a lot about like what happens at the end of the day, like how does the software actually perform in real life and all of that, versus like more hypothetical or theoretical stuff. So yeah, so that's kind of how I got into all of this stuff and what I've been doing for the last 15 years or so. And most of my work is open source, so I put my GitHub there. The stuff I'm working on right now is not open source, but it will be sort of freely available, at least to start. It can't make any promises about open source licensing, but it will be freely available to use. So, and I should say it already is, but we're releasing a whole new basically version of the code probably like tomorrow or something like that. So it'll be very new very soon. Okay, so let me just dive right into LLM and AI agent applications. So here's some common design patterns. So just to sort of like set the stage, what I'm talking about today is like LLM sort of single purpose applications. So this is not like benchmarking foundation models. It's actually not benchmarking at all. So this is just a distinction between the word benchmarking and eval, is like benchmarking would be over, to get a generalized estimate of how the algorithm or software performs in a wide variety of cases. So what we're talking about today is just evaluating single applications and how to do that in an automated fashion. So there's a couple different design patterns that are popular with LLM applications. So of course we all know the chatbot, the Q&A chatbot, that's like what ChatGPT is. Or you can, have a custom prompt and have a variant of that. You can fine tune models, but basically text is input, text is output. That's what I'm talking about there. Then there's RAG, which I'm not sure how many people are familiar with RAG, but that's retrieval augmented generation, and that's the same on the surface interface. Text goes in, text comes out, but there's a number of different intermediary steps in between. And so you basically augment the LLM with some kind of data corpus, whether it's a bunch of documents, a bunch of PDFs, whether it's a database, something static can be updated, but generally the idea is that it's static. And there's a lot of these, basically the retrieval step is the hard part of this. So retrieving the right set of chunks of data to basically inform your LLM to make a smart response based on actual data from like real sources. So that's the hard part. So that's where things tend to go wrong, and like where we have a bunch of RAG specific metrics that we can use to sort of evaluate whether or not that's the part that's not working, or is it the generation piece. So you kind of have to like tease these things apart and know where all the different places that you can evaluate. And then the last thing is kind of, it's not necessarily different from these other things, but something we also talk about is structured output. So you might have input, like normal text going in, but the output has some kind of data structure, whether that's JSON or maybe it's a CSV file, Markdown, etc. Just another kind of slightly different design pattern. Okay, so as you know, like evaluating machine learning models, we have multiple different types of things we can measure, like accuracy, inference speed, fairness, like there's a handful of metrics, but they're all pretty well known, well understood, unless it's some kind of custom business metric that you've handcrafted yourself. But we're all familiar with basically how to evaluate machine learning models. And evaluation has always been multidimensional. You have a number of different things, and sometimes they kind of fight against each other. For example, accuracy versus inference speed is one where it's kind of a trade-off between the two in some cases. We saw a lot of that in the AutoML world. But with LLMs, it's just like a whole gigantic space of new metrics, and it just kind of blows up, basically. So a couple other challenging aspects is, as you probably already know, LLMs have probabilistic outputs, and there's no like single correct answer. The evaluation depends on the context. So whether maybe you have this short answer to a question in one domain, and that's a good answer, but same answer to some other domain, it's like not good for some reason. So, and of course we can set the temperature parameter of an LLM down to 0, which should reduce the randomness to some degree, but it's not gonna make it reproducible ever. So so that's just a messier thing about LLMs. So this next one is probably the one that like is the most crazy out of as people like ourselves who are used to like, we really have a lot of respect for reproducibility and like understanding when things change and how to like, I don't know, having version numbers that are unique and not having let's see, how do I say this? When we get a model and it's a, let's say XGBoost version, blah, 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 we expect that code to be the same and to produce like the same output for the same input like forever, and it should not change. However, with commercial models like OpenAI, LLMs, Anthropic, Gemini, all of them, they basically don't have that guarantee. Even if the model version number is exactly the same, they're constantly updating and patching these models, and there are lots of regressions, and things are just not stable. So of course, if you have open source LLMs like Llama, et cetera, you have more control. But a lot of people are building applications with OpenAI models and Anthropic models, and you basically just lose this component that's pretty useful to have if you're doing evaluations. So I'll say something about like all the metrics are rather like subjective. So is something helpful? Is the response helpful? what is the tone, the bias, like all of these things are very fuzzy metrics to begin with, even if you asked a human. So of course that makes more challenges. And then evaluation costs and scalability is the other big challenge. So, you know, you can score 100,000 row test set on like some AUC metric and it's like instant and you're done. That's sort of very automated, very easy, very scalable. But if you are evaluating an LLM, there's a much bigger cost. Like we do have some metrics, which I will talk about, that are kind of more like AUC. They're like basically text, old school, like NLP text metrics, which we can evaluate pretty cheaply and scalable, but they're not as useful as something like what's called LLM as judge, which I'll get to as well. And so this thing that I mentioned before, I just want to kind of emphasize it because I think it's just so kind of insane that they do this. And I didn't even realize this was happening for a long time. I just assumed, oh, model version means that you don't change the thing. If you need to change it, you release a new version. This is how we do software, like since forever. So I just want to highlight, here's just a couple examples of things that have changed, like in the last couple of GPT models. Probably like the worst one I would say is this one in October 2024 where function calls, which is a part of when you have, well, I'll talk more about AI agents, but when the LLM makes a function call, you expect to get like structured data back typically. And it was just like dumping text all of a sudden. And so like, if you can imagine using this in like a data pipeline, it's just like immediately going to break everything. And like everyone just got very upset and like they like, I guess, fixed it. But then, you know, by then all the damage is done and you don't have any, there's no recourse because I don't know, I guess there's sort of the move fast and break things ethos going on in these companies. So, and I put this one on this slide today because there was like a new thing that happened today where Anthropic kind of like this morning, somebody posted this on my work Slack, which is how I know about it. But, you know, there's some model degradations that they finally like realized were happening last week. And apparently they've fixed them. But like, this is just kind of, you know, this is just how things go in LLM world. And I have this tweet on the side here. It's from a few days ago, last week. Some quotes like from an interview, someone interviewing an Anthropic person. And basically like, the other thing is like they just, there's not a lot of evals happening in the first place, I guess, is sort of what I hear. Like I don't work at those companies, so I can't say for sure. And I'm sure they can't really say either, but yeah, I mean, there's a lot of sort of, what do they call it, like vibe checking. Like they just talk to the LLM a little bit and like feel like, oh, this feels like it's working. Okay, push to production. And then, you know, who knows? So, so there's even sort of a debate of like, do we even need evals in some sections of the AI community? So, I mean, I would assume people here would probably think the same way I do, is like, of course you need evals, but I guess that's, you know, up for debate. But anyway, I actually, I asked ChatGPT after reading this, you know, why would a company like not want evals? And it was just kind of an interesting answer. It was just like, oh, well, then the developers would have to like constantly validate new models like all the time, make sure they work. I'm like, yeah, they would. That would be a thing that they would want to do. Yeah, so crazy times. So anyway, to kind of summarize, traditional ML versus LLM applications, you know, we're dealing with discrete structured data. We have open-ended probabilistic in LLMs. The metrics are very different. They're much more easy to understand in traditional ML and very open-ended, loosey-goosey in the LLM application section. Evaluation cost, very cheap in traditional ML. With LLM applications, depending on how you do it, of course, if you don't do evals, it's free. So it depends on what you're looking for. But it could be semi-automated. Typically, there's humans in the loop, and that's kind of what you'll notice through the rest of my slides is sort of that's kind of a thing that still has to happen for now. And I've already talked a bit about the stability, so I'll skip that. Okay, so I just want to show you a couple like diagrams of what an LLM application looks like. So I'm starting with just what we know already, which is a machine learning system. And this is kind of your typical machine learning pipeline. You have features that are generated by either a user interacting with it or generated somehow by the system. Maybe you do some data processing, you send that feature set to the model. So let's say it's just a GBM, makes the predictions, and then it surfaces in the app somehow. And maybe this would be like determining what product to show you on an e-commerce website or something like that. And then maybe you log some of that into a logging system. So this is pretty small, pretty simple to deal with. So now I'm going to give you an example of just a data processing pipeline that involves an LLM. So this is this hypothetical example is like a medical research RAG system where, let's say you have a bunch of research papers, it doesn't have to be medical, it could be anything, that are sort of updated regularly. So new publications come out all the time. We don't want to just have a RAG system that knows, all the information from the day that you built it. We want to be able to update that nightly with any kind of new papers. So one thing that we might want to do is like run a cron job, looks for new articles, finds a new article. We might use an LLM to actually extract the metadata out of that article, like author, date, journal, like study type, that type of thing. And the reason that we do that is with RAG systems, they work a lot better if there's metadata on all the chunks. So it's a totally optional step, but this is something that people would do. So we use an LLM to process the thing and grab out all the metadata that we want. Then we embed that document with its metadata into this vector database, and then that powers the medical QA bot. So there's actually a couple different LLMs, in play here. So this just goes to show like kind of how complex things can get, and like people are putting LLMs all over the place. And I've seen like things that should be maybe even a simple Python function. They're like, oh, who would answer that is an LLM. So they like replace, so I've seen things. Okay, so just to kind of highlight, so what are the properties of LLM systems? So what we just talked about, they're very multi-component. Like, of course, machine learning applications can also have multiple components, like whole feature processing pipelines and things like that. But as I showed on the last slide, that can be more complex, and there can be LLMs, everywhere in the pipeline as well. And so this is the thing that I'm still upset about, is that models can shift under, like, right from under you, even if you don't change your code. You don't change the model number, you don't do anything. All of a sudden, the model is producing different output than it would before. And then, of course, we have the obvious thing, which is that these things are non-deterministic in general. So on top of all these other issues, like, you don't have any determinism in what it's going to produce from the same output day to day. Okay, and I'm just going to talk a little bit about agents, because very similar to just an LLM system, but it's essentially a controller that interprets a user request. And the only difference between an LLM application and an agent application is that an agent has access to tools and can do function calling. That's it. So, and everything's an agent now. So, so I think it's just good to talk about that, because with the function calling, that just introduces a lot more places where there can be errors. Like, what if you're using an API to get some data and all of a sudden the API is down? Or what if it gives back something unexpected or something like that? I mean, we hope that APIs are pretty stable, but you're introducing more unreliability in the system as soon as you have an agent. And the same task, like if your task is build me a travel itinerary and book some tickets or something like that, there's a lot of different ways that you can do that. So there's there's a lot more paths to get to the solution than a simple like input output text. And if you have an error at the beginning of the path, that cascades to down, down the path and can create a lot of additional issues. And sometimes these agents work over time, like they might go off and run a compute job and then take the results from that and then like do some other things. So it's sort of a longer time horizon. It makes it a little bit more complicated to do eval if like just takes a long time to do what it's supposed to do. Okay, and this is an example of an agentic system. This one is not hypothetical. This is one I have built just as a prototype for testing the software that we have at Distributional. We need to have agents to be able to test them. So built this little it's called financial research agent. You can basically ask it questions about companies and like what's going on with this and that. And so it has a number of different tools that it can use. So one is to get the stock symbol, like, because when a user types in, what's happening at NVIDIA today, like NVIDIA is not the stock symbol, so we need to somehow interpret like and map that to like a unique ID. So it would do that. Then it would go out and use different APIs to get the price or the news, and it would bring it back and then answer your question based on these things. And then it would also be sending that data to some logging system as well. So that's just kind of a very simple example of what an agent can look like. So, all right, so this is just the general eval section of my talk. So here's some examples of things that you could evaluate in an LLM. So there are some overlapping goals. Like for example, like accuracy is both a concept in machine learning, but also in LLM eval. Like, does it give you the correct answer? That might not always be the appropriate question to ask in an LLM. Like, there are factual questions that you can ask that have real answers, and then there's more subjective things that you can ask that don't have like a correct answer. So it just depends what your application is and whether that's applicable. Of course, we always want to ask, like, are the claims true from the LLM? And if so, like, it's great to use like a RAG system or something like that where you can cite the source, like in an actual PDF or document or something like that. Helpfulness is just kind of, if you're building these things for users, you probably want to have some measure of like, is this helpful to people? Or you can infer that if people stop using your app and things like that. But these are just different questions that we can ask. Safety, does it, avoid harmful or biased outputs? And can it generalize? That's also something we look for in machine learning, is can it generalize? But the metrics themselves are very different. So I mentioned before, there's some kind of simple metrics that would be like the equivalent to accuracy or AUC or RMSE or something like that. And I'll go over those in a second. So here's some of those metrics. So these Blue, Rouge, and I think Blue, Rouge and Perplexity are all pretty older, like NLP type metrics, and they just look for like overlaps in the text from an answer to an output, or sorry, an input to an output, things like that. So they're not really measuring anything really quantified, like it's not answering any of those questions that I had on the last page, but it is telling you something about the similarity of your question and your answer. Maybe more a little bit sophisticated version of that is something called the BERT score, where you embed the question and the answer, and if they're close in the embedding space, then that tells you something as well, but it's still a little bit not interpretable. So, and then of course, if you do have an LLM where you have structured output and the answer is like 0 or 1 or true or false, you can use things like accuracy, just as we are used to. But yeah, there are the limitations are that they're not super interpretable in terms of what they actually mean. Although we could probably make that argument for things like RMSE and AUC and whatnot in certain cases with machine learning as well. Okay, so the LLM people have invented a new word. It's called golden data sets. It's basically your test set. But I mean, maybe people outside of LLM world use that, but they like to call it golden data sets, but they're basically your test sets. And generally, I mean, when you use that term, it means like a human has looked over the data set and it's sort of like your real ground truth. So, so this is how humans start to become in the loop. So one is we need help from humans to create the validation sets or the golden data sets. You can either just write them, yourself, just get on a computer, start writing input-output pairs that look like, what you would think, or you could use an LLM to generate the input pairs and you write the outputs, or you can use an LLM to do both and you can just read through the outputs and see if they're good and then change them if they're not. You can also do like binary feedback plus or minus on the generated responses. So these basically I'm going in order of like how much human intervention is necessary. And then another thing that I'll talk about later called error analysis is sort of you have a bunch of traces, let's say they were either automatically generated or they're from a live system and you're just grabbing real data. You can basically write your opinion like, oh, this answer is good, but it's too short, or this answer doesn't really answer the question, or blah, blah, blah. So you can annotate things as well. So yeah, so limitations. So unlike in traditional ML, your test set is hopefully probably close to the real data, at least when you first launch the model. It might shift over time, but generally that's not hard to anticipate. I mean, maybe it is, but I feel like with LLMs, it's a little bit harder to anticipate how people will actually use your system. And it's a much more like, I don't know, adversarial way of thinking where you're like, oh, is somebody going to type in this and then what would be the response? Or someone kind of trying to hack like the prompt or, it's a little bit harder to predict what humans will do when they're talking to an LLM versus generating data by interacting with a website or something. So there's a bit more issue with assuming that your development process on your validating your model on a golden data set is going to sort of carry you forward. And so I would argue that you actually have to like continue to collect this data in production and like repeat this process and kind of have like a cycle going on. Okay, so one thing that we can do to automate evaluation with LLMs is called LLM as judge. And yeah, this is very, very common. It's not always done well, but it's very common to do this. So yeah, and it's very easy to make a judge. And on the next page, I'll show you an example of what a judge might look like. But basically, it's just a prompt that says, here's how to evaluate whether or not this is good. Give it a score on this axis or this axis. You can ask it to do one, evaluate one component of a response, or you can ask it to evaluate like 5 or 6 or 7 different things at once. There's probably trade-offs in terms of like computation time and things like that, if it's like more efficient to try to just ask it to do everything at once, or there's things like this that you can think about. But in terms of the prompt itself, some of the limitations are, for example, there's kind of a I guess rule of thumb that like you don't use a judge model that's the same as the one that produced the text. So if you're using GPT-4o in your app, don't use GPT-4o as the judge model. Use something else, Gemini, whatever, anything else. Not the same one, because it definitely prefers, it sort of has a bias towards its own output, I guess. And then, yeah, so the thing, people love making judges and they're easy to make and they're easy to deploy, but they're not necessarily easy to validate that they're actually doing what you want it to do. That's the hard part, and that's still kind of the manual part in this process. There's a post at the link below. There's this guy, Hamel Hussein, who some of you might know. he's done a lot of writing about LLMs and eval. So he's kind of like the go-to person for me to like read, and we've worked together before as well. So he's a really good a really good resource if you want to learn more about this stuff. So here is just an example of what an LLM as judge might look like. Just kind of, here's your, it's sort of a formal way of writing, but it's just kind of pretty straightforward and readable. It's going to say, here's the things that you should check for, and here's what I want the output to look like. This is a very simple one. And you can ask it to rate it on like a Likert scale, so 1 through 5, or you can ask it to say, like, is this good or bad, like a binary thing. Hamill has some opinions about why binary is better than Likert scores, if you want to read about that there. And here's just another one. These are both for the financial research agent. So you can have multiple judges on one agent. So this one is more interested in checking like the actual data that was retrieved by the tools was processed correctly and is given back to the user correctly. So there's all these different aspects that you want to measure. And then I've talked about RAG before. So RAG has its own set of metrics. It's called the RAG triad, and it's kind of this, you know, there's a query, it goes and gets some documents, that's what's called the context, and then you can ask, is this context relevant to the query? You don't need ground truth for that, but you can ask an LLM as judge to answer that question for you. Then once you have the context, you say, and it generates the response. Is the response supported by the context? So that's called groundedness or faithfulness. And that's another thing you can use an LLM as judge for. There's also like some of these metrics that I've talked about before that look at kind of just text similarity and stuff like that. You can use as well if you don't want to use LLM as judge. And then answer relevance, like, is the answer relevant to the query? So this is just, these are the metrics that you would look at if you're using RAG. Okay, so I mentioned before, you can make these judges pretty easily, but how do you know if they're working? So, well, one way is that you just manually look at all the data and see how it's grading things and then decide if you think that looks good to you. But then there's the question of, okay, if it does not look exactly like what you had hoped for, how do you align it with your expectations so that it is actually good? And so there's this sort of process or pipeline called eval-gen. So this is, I put a link to the paper. This is by Shreya Shankar, and who's kind of an associate of Hamill. They do a lot of work together as well. She's a PhD student at Berkeley, and I know she's looking for an academic job next year. So if anyone, I don't know what the status of that is, but I know she's going into academia and wanting to do this more. So she's come up with basically a framework by which you can align your human feedback with the judge, and you can like basically you basically select these implementations that better align with your grades. So you do have a process of like manually looking at the output, but what you get in return is a more aligned judge. And so that is a handy way. So again, this is not fully automated, but these are steps in that direction. And like maybe in another year, there'll be another version of this where it is even more automated. I'm not sure. So people are working on trying to solve this. And then there's something that's called, they call it LLM error analysis. And that's just essentially a name for systematically going through like your logs, looking at the input-output pairs, and the the process is you make the annotations of like what was wrong about this, what was right about this, and then you just look through it basically. It is a manual process, but at least you can, at the end of the day, get some sense of like, are there certain types of errors that are happening a lot? Are there some that are happening a little, and you kind of even like cluster on the errors basically, and then you get some sense of like what is going wrong in your app. And basically you just do that until there's nothing left to learn and are happy with the performance. And then, you might launch a new version of your app, collect more data, and like repeat the process. But there's a video here. Also, if you just look up Shreya and Hamel, and error analysis, you will find this on YouTube, and they'll teach you how to do it. And they also, because we're AI people, in the video they actually vibe code using a cursor, I think, just a little UI to do this easily. So I think the point of that is them showing you it's actually easy to do this, and you just need a nice interface. I think Shreya cares a lot about if there are going to be humans involved, let's make it actually enjoyable to do this work instead of I don't know, downloading a CSV file, stuff like that. So I think her point is to say, oh, it's really easy to just code up a little UI where you can do this type of analysis. Okay. So I mentioned this kind of dichotomy before between development and production. So, in machine learning, most of what we do is in development. It's doing, model comparison, hyperparameter searches, all of that stuff until we feel really good about our model. Then we put it into production and then maybe put a simple drift detection on, the predictions or the feature data, and then monitor that over time, and you probably feel pretty good about it. Maybe an anomaly detector or something like that. So I'd like to argue that that's not enough for LLM applications. So, and just if you haven't heard these words, I mean, I think we all know offline, online, we know what an online algorithm is versus an offline, that type of thing, but just they're reusing the terminology here for eval. So offline is dev, online eval is eval in production. So there's just some terminology, but basically, yeah. So offline evaluation, really it's in service of model selection, model upgrading, improving your model. And then once you have that online, we need to monitor how things are going, and then things might get weird. So yeah, so just I think I've kind of talked about a lot of this stuff already, but here's just the core properties of offline eval is you have these golden data sets. These are high quality labeled examples for your task. Everything is, I mean, I won't say everything's reproducible because of all the issues that I talked about before, but it's much more reproducible when you have fixed data sets that you're testing on, that type of thing. And yeah, this is some offline metrics, so all the metrics can be used either online or offline, but you tend to have different sets of metrics that you look at in an online versus offline setting. But yeah, I would say that you can do all of this stuff. I mean, you want to front load a lot of this stuff before you deploy the model, although we don't see that all the time. Sometimes people are just vibe checking their models. They put them into production. They're okay, I'm just going to wait till I get real data so I can really understand what's going on. And there's something to be said about that. But yeah, so I do want to mention there are some open source libraries that will give you all these functions, for free. So all the stuff that I have talked about, well, I'm not going to go all the way back, but Rouge scores, Blue scores, all that stuff, all the RAG metrics. That's basically a list of some open source libraries where you can just get all of those functions, because you'll want to use that in your evals. Okay, so now we shift to online eval. Yeah, I mean, I don't want to go too far into this because I want to leave time for questions, but a lot of these concepts are probably familiar if you have worked in industry and doing machine learning in production. But yeah, I think I'll just skip kind of over this, but I guess I'll talk more about some of these things next. I do want to mention you do need to be logging your data if you want to have your data. So one of the, I would say your app is not done until it's sending traces somewhere, whether that's a local thing that you've set up that's open source, or there's like free stuff on like Langsmith. There's a company called LangFuse, which has an open source tool. And they basically all just look like, a dashboard with a bunch of rows that are your traces. You have your input output pairs. And then if you click into one of those traces, and of course, trace is just the name for sort of the process of input, like sending input to an LLM, it generating an answer, and then like a story. It's like everything that happens in between. So it can be including function calling and other things in the middle, but that's what I mean. It's sort of like one observation. It's an input output pair and everything in between. So this is what like a trace, this is called a waterfall plot. They have this kind of visualization on all of these tools, but this is from my financial research app. So, first, this particular one is like a multi-turn app. So it will remember what you've just asked, and it has a memory, and so this is just one input output pair within that memory. So the first thing you see there is like conversation context injection. That's just a process of like putting the context in there. Then it might like use this tool called search symbol. That's the one like searching the stock symbol. Then it like talks to ChatGPT again, then it gets company info, and it's like, that's what it looks like. So yeah, so just start logging your stuff so that you have data that you can play with. Okay, and so almost done. I want to leave time, at least 10 minutes for questions, so I'm going to go a little bit quickly over the last stuff, but there's something that I would call LLM analytics. So I would just say what that means is any kind of analytics or like data analysis on sort of the exhaust from these systems. So that could be doing like text analysis on like the inputs or the outputs, or clustering the data, because you kind of want to know like what is going through my system, like what kind of insights. And because this is like text data, we can make like human interpretations of what people are talking about. Unlike, numerical machine learning data, it's a little bit harder, I guess, depends on what you're doing, but like if you have interpretable features, you can do that, but a lot of times we don't. So I want to point you to a paper by Anthropic from December 2024 called CLIO. So CLIO stands for Claude Insights and Observations. So they wrote this whole thing about basically they're just topic clustering to figure out what people are talking about, essentially, but they want to do it in a privacy preserving way. So they have this way of doing that. And that would be one example of like LLM analytics. There is an open source reproduction of Clio that's called Cura by Jason Liu. Jason Liu is another person who's kind of well known he's really a RAG expert, but he's also into evals and stuff like that. Also someone that I've worked with. So that's his implementation. And we also have our own implementation of this as well, which is coming out. I mentioned to someone before this talk that like we're just finishing this like major release of our product. We're redoing a bunch of stuff, and it's supposed to be done like tomorrow. So I've been like really busy the last couple days, but this will be included in that as well. So you can try that. And this is stuff that I've worked on. So another thing, anomaly detection. It's like good that we know how to do all these like data science things from before, because they're actually coming into like, they're very useful to like analyze the data basically. Because, you have all this data, you want to analyze it. Probably everyone in here has done some anomaly detection before, and they know how to do that. So that's also stuff that you can do in these sort of analytics systems that sit on top of LLMs, is just like look for anomalies in these either like numerical things like response time, token count, or you could even do text embeddings, take the input, embed it into some high dimensional space, take the embedding, maybe it's like, 758 dimensions or something, and then you can put that as features in your anomaly detection. So there's lots of things that you can do. And that's something that I'm also just added into distributional. This is just a little screenshot of Clio. It was just nice looking from their website. Just kind of shows how they take conversations and then they do this thing where they sort of summarize what's going on. It's like a bunch of layers of summarization. That's how they get the privacy. And then they cluster it, and then they have these hierarchical clusters. And then you can kind of see, like, this is what people are talking about on Claude, and then that's kind of useful to know if you're the developer of Claude. It's also interesting, just out of curiosity as a person, like, what are people doing with these things? Because, like, I'm very curious and maybe like horrified to know, like, what kind of things people are doing. And then lastly, once we have all this data, like the eval data, the analytics on top of these other things, we basically like need to write tests. So we want to, so it is interesting to know, like, oh, there's these types of clusters with this distribution, like on the last page. Like, it's interesting to know this, but what would be even more interesting is to know if that's shifting over time. Because then, like, I don't know, that either, like, in terms of topic clustering, that's just maybe another sort of interesting thing to know. But if it has to do with like things that matter, like latency, if all of a sudden latency is like getting longer and longer and longer over time, like, that's something to be concerned about. And that's the kind of thing that you would want to write a test for. So by testing, I just mean sort of taking this data and like creating assertions that you want to look for, and then just having that run like automatically on the logs. So like, and then looking at, like, I think on the next slide, this is why our company is called distributional, because we are looking at distributions of data like over time, and we're also like all like stats ML people, so we like distributions. So yeah, I mean, I think and you can create like, so you have like all these metrics, unlike having just like accuracy that you're tracking over time. You have like maybe 100 different metrics that you can derive from these logs, and then you can like, track the like joint distribution of these things over time, and you can just get these very high level, rich layers of information on top of all this. So that's kind of, I think, my last slide is, so I don't know did I answer the question, like, can we automate LLM evaluation? I would say not yet. I don't think not yet, but there's certainly people trying to do that. And I hopefully have pointed out all the places by which you can automate things, and like the risks of doing that, and then like how to manually check those things, like how to test your judge to make sure it's actually producing quality judgments. And then, we just sort of keep automating things until we run out of things, and then eventually maybe it'll be all automated. Like a couple of years from now, I'll come back and we'll talk about that. But I think, I'm not saying like it's good to automate everything, but as anyone who's in this room, it's like just sort of a passion of ours, like to automate things. So I think we'll just keep trying to do as much as we can and just figure out how to keep humans in the loop. I think there was a talk about that earlier today. And yeah, so I think that's it. And here's some resources. I mentioned Hamel and Shreya. And then that's me if you want to connect on LinkedIn. And if you want to, I actually don't have a link to point you to where you can download distributional, but if you would like that, send me a note on LinkedIn, and then our new thing is gonna be released very soon. And so I would like to point you to the new one, which is all the stuff that I talked about. And that's it. Oh yeah, so we have a few minutes for questions.